Alice, Bob, and Eve explain Grover's algorithm.
I've been trying to find the one key that unlocks my diary for ages. There are hundreds in that large box with all the keys we have at home since we moved last year.
What you're doing reminds me of Grover's algorithm in quantum computing.
Oh yes, Grover's algorithm. It's one of the most practical quantum algorithms for searching unsorted data.
How does a quantum algorithm relate to my key search?
Well, classically, like you're doing now. If you have n unsorted items and need to find a specific one, you might need to check up to n items in the worst case.
If you have 100 keys, you might need to try all 100 before finding the right one. On average, you'd expect to check about 50 keys.
That's exactly my problem. So how would Grover's algorithm help?
Grover's algorithm uses quantum superposition and a clever technique called amplitude amplification to find the answer in roughly the square root of n steps.
For your 100 keys, instead of 50 checks on average, Grover's algorithm would need only about 10 quantum operations.
That sounds like magic. How does it work?
First, it puts all possible solutions into a quantum superposition. Imagine all keys existing in a quantum state simultaneously.
Then it uses something called an oracle, a special function that recognizes the correct key, to mark the right answer.
After marking, the algorithm applies a process called diffusion or inversion about the mean, which increases the probability of finding the marked item.
It's like slightly elevating the correct key above all others. Each time we repeat the marking and diffusion steps, the right key gets elevated higher.
How many times do you repeat this process?
About square root of n times. After that, measuring the system will give us the correct answer with high probability.
It's like having a special kind of magnet that gradually attracts the correct key, making it more likely to be picked when you finally reach in.
So for my 100 keys, I'd need about 10 iterations?
Exactly. And for 1,000,000 keys, classical searching might require 500,000 checks on average. But Grover's algorithm would need only about 1,000 iterations.
The quadratic speedup becomes more dramatic as the search space grows. For very large databases, this could mean the difference between minutes and days.
What kinds of real-world problems could this solve?
Any unstructured search problem, finding entries in databases, solving certain optimization problems, or even breaking symmetric encryption, which is why we need quantum-resistant cryptography.
What makes Grover's algorithm particularly important is that it's proven to be optimal. No quantum algorithm can solve unstructured search problems faster than square root of n.
So while I keep searching through my keys one by one, a quantum computer could be finding my diary key in a fraction of the time by elevating the right answer above all the wrong ones.
Exactly. And that's why Grover's algorithm is considered one of the most practical applications of quantum computing, once we have large enough quantum computers to implement it.